In this lesson, we'll go more in-depth with Pi server deployment, hardware, and installation recommendations. At the beginning stages of implementing a new Pi system, it's important to understand some of the prerequisites and OSIsoft's best practices. This helps ensure that the server is built to handle all current data needs, as well as to minimize periods of extended maintenance. When deciding the number of machines required, it ultimately depends on the size and complexity of your Pi system. This factors in the number of Pi points, number of units to represent in the Pi AF server, usage of redundancy, the amount of data online at once, etc. A simple system will have the Pi data archive, Pi AF server, and SQL server on the same machine. By small, I mean around 25,000 Pi points or fewer, and 10,000 or less Pi AF assets. And by the way, the SQL server is a prerequisite when you're installing the Pi AF server. When the Pi system begins to expand, the setup is no longer recommended, as each part will begin to demand more and more resources on the single machine. When you start to go higher in point count and Pi AF assets, this is the next recommended architecture. It's very similar to the environment that we'll have hands-on access to in the virtual learning environment, which we'll look at later. The Pi AF server and SQL server are hosted on their own machine, while the Pi data archive is on a separate machine, providing better allocation of resources. You'll notice two Pi data archives on two machines and a Pi collective formation here. When multiple Pi collectives and redundancy in the Pi AF server and SQL server are needed, you may work towards an environment that resembles this. This is more of a true distributed system that handles the largest workload so far. While the biggest trade-off has to do with understanding and maintaining multiple machines, you get the best level of performance and scalability. For a completely new Pi system, the second architecture is a great place to begin. It can start out small with only a few Pi points, and you can eventually scale out by attaching new machines into the picture. Now, if we look at the individual computers, OSIsoft provides a hardware system sizing recommendation spreadsheet, shown here, which helps with selecting hardware for Pi system applications. This file can be downloaded from the OSIsoft technical support site, and it's also located on the machines in the virtual learning environment. Here's the hardware sizing spreadsheet in Excel. At the bottom, you'll find a number of tabs, each corresponding to a different Pi application. And on the Pi Data Archive tab, for example, you provide values for these yellow cells with your expected parameter values. If you're unsure what certain cells are asking for, you can click on them and a description will be provided. The red cells underneath correspond to both minimum and recommended hardware sizes. Let's go through an example. I suspect there will be 10 interface nodes in my Pi system, so I'll input 10 there. My scan rate will be about a minute, nothing faster. And the amount of data I need online at one time, let's just say it's a year's worth. I will implement a Pi collective with 3 different nodes, and the rest I'll leave at the defaults. If I go scroll to the bottom, I can now view minimum sizes as well as recommended sizes. So here, I'm told that the recommended archive size is about 256 megabytes, and in order to have, remember, a year's worth of data, I need to have about 74 gigabytes of archive storage files. And I can see how much RAM, and it's rather small, but this is a recommended value. My CPU count, and you have information on network and disk I/O. And feel free to experiment with these values. If you're not sure of the effect of a certain parameter, see how much of a difference it makes when you input both a conservative and then an extreme value. At the bottom, there are a handful of specific references, like software requirements on the PyData archive, and as well as details on PyArchive sizing. Moving on to some notes on installation. With only a single drive available, the PyData archive will install all of its components on the single drive. This includes binary files, PyArchives, and more. And this is not the recommended approach for a number of reasons, including optimizing disk I/O, scalability, disaster recovery, and more. OSIsoft recommends at least 2 physical drives on the PyData archive computer. In this scenario, the second drive will be responsible for PyArchive files, separating out the main data storage. These archive files experience a great deal of read and write burden and are the best first target to remove from the rest of the PyData archive. Optimum configuration of the PyData archive requires up to 5 different hard drives, each corresponding to one of the categories in this chart. This configuration best distributes disk I/O for each component, as well as dedicating a well-defined portion of disk space for each task. In our virtual learning environment, we'll separate out PyArchives, event queues, and PyBackups from the rest of the PyServer files. One note about virtualization: OSIsoft fully supports virtualization of the Pi system. 2 examples are Microsoft's Hyper-V platform, as well as the VMware server. When you're sizing Pi systems using the sizing recommendation spreadsheet, all of the hardware sizes apply the same to virtual machines. And as with on any physical piece of hardware, you should also test new Pi systems on virtual machines. With these recommendations in mind, it's possible to start drawing a layout for your Pi system, whether it involves putting the majority of the Pi components on one machine, or a larger architecture involving redundancy, like for the PyData archive. You're equipped with knowledge of hardware requirements to ensure your servers are built to handle load from users, as well as best practices for installing the PyData archive.